Okay, so we are doing 2.5, which is absolute value functions and graphs. So really our goal today, and that is our objective, and that's to graph absolute value functions. So we have seen linear functions. Linear functions are a nice straight line, okay? That's nothing new. But let's talk about what an absolute function, kind of its structure, and how we go about graphing it. So the absolute value function takes the form of y equals the absolute value of mx plus b plus c. Okay, so that's kind of its general form, the bare bones, kind of the skeleton of the absolute value function. Now the other thing is its shape. It is a V shape, okay? So it will either look like a normal V or an upside down V. And that depends on the sign in front of the absolute value, which we will address coming up here in a moment, okay? So let's actually go ahead and just look at some problems. So looking at page 88 and 89, number 21 from it, we're going to take a peek. So I have y equals the absolute value of 3x minus 6. So first of all, you have to find the vertex of the absolute value, because if it's going to have the V shape, you have a vertex, and then it's basically symmetrical. Like you kind of think back to grade school when you did symmetry. So an absolute value function is going to be symmetrical. Now, the one thing is, and your book will show you that to find the x value, you just do negative b over c. Okay? I mean negative b over m, excuse me, for your x value. But let's actually talk about it algebraically. The big thing to remember is that absolute value, the definition of absolute value, is a distance from zero. That's why absolute value is always positive, because it's a distance, and it's a distance from zero. So actually what I do, so first I need to find the vertex of my absolute value function. Okay, my vertex is going to be a coordinate of x, y. To find the x value of the vertex, I actually take the guts of the absolute value, so that 3x minus 6, and I set it equal to 0, because remember, absolute value is a distance from 0. So I have to find out what value for x makes that whole absolute value equal 0. So I'm going to solve for x. So I get 3x equals 6, and then x equals 2. So the x value of the coordinate is 2. Then I have to find the y coordinate. The y value of the coordinate is actually whatever your plus c is, or it could be minus c. There's nothing there. So because there's nothing there, that means that the y value is 0. Okay? So the big thing to note is that the y value of the coordinate will always be whatever c is. You know, so if it's minus 3 after the absolute value, then it'd be a negative 3. So that's kind of what you want to keep in mind. Okay? Now the vertex, that's something that everybody should have the same. Everybody should have the exact same vertex. After that, it's kind of up to you. Okay? So with our V, and one other thing that I do want to explain is, if you notice outside of the absolute value, it's positive. Whenever it's positive outside the absolute value, it's going to take a normal V look. Okay? So with our vertex, you have values left of the vertex and values right of the vertex. So basically you want to find a left coordinate and you want to find a right coordinate. So at this point, and this is what freaks people out, which I never understand, you get to choose, okay? You get choice, which is very exciting, but some people don't know what to do with choice, okay? So basically, what I have to do is I have to choose a value for x that would be left of 2, okay? So I could choose 1, I could choose 0. I could choose -10 if I want to. The possibilities are endless. It's so exciting, but some people freak out over it. Okay, so just relax. Pick something left of 2. So like think about a graph. Here's where 2 is. Something left of it. Okay, anything. I personally choose something close to the vertex, so I'm going to choose 1. Okay, that's my personal preference. You can choose something different if you want. And then you have to choose an x value that's right of the coordinate. I just realized I spelled right wrong. Sorry about that. So I have to choose an x value right of the coordinate. So an x value right of 2 is 3. Okay, so it seems a little bit cattywampus, like it's out of order, but maybe, you know, drawing that little squiggly like I did, that the vertex separates and I have to pick something left and something right. Now what I need to do is I need to actually calculate what y is going to be. The y is only the c value if you're finding the vertex. Anything else you actually have to substitute it in and find out because it's y equals. So let's go ahead and find the y value for the left coordinate. And so for the left coordinate, it's y equals the absolute value of 3 times 1 minus 6. So 3 times 1 is 3. 3 minus 6 is -3. And the absolute value of -3 is 3. So my left coordinate, the y value is 3. Now let's talk about my right coordinate. So my right coordinate, I have y equals the absolute value of 3 times 3 minus 6, and then I finish the absolute value. 3 times 3 is 9. 9 minus 6 is 3. So the absolute value of 3 is 3. And you might be sitting there like, what? Say, what? I got the same thing. Okay? That's good. That's actually a good thing. Because if you notice that this 1 that I chose, it's only 1 away from your vertex. This 3 that I chose, it's only 1 away from your vertex. So if you choose a left and right coordinate that is equidistant from your x value of your vertex, then your y value should actually be the same because it is symmetrical. Okay? So at this time, we would go ahead and graph. So we'd utilize our points. Let me get some graph paper here. Okay, maybe I'll do the large. There we go. So I'm going to go ahead and graph. Oh, that's a little bit ugly, but hopefully you guys will deal. So I'm going to go ahead and graph my vertex, which is at 2, 0. And then my left coordinate, which is at 1, 3. And my right coordinate, which is at 3, 3. And then I just connect it and I draw arrows because obviously this graph will go on forever and ever and ever. Okay, and that is it. Now I have graphed it. So basically, whenever you graph an absolute value function, you always need to find your vertex, find a left coordinate, and find a right coordinate. You do need to get 3 points in order to graph an absolute value function. So let's now look at number 22. So number 22, I have y equals the negative absolute value of x minus 5. So notice that I have a negative just outside of the absolute value. So just in front of the absolute value. So that's like a -1. Okay? So I have -1 times that absolute value. What that does is it changes the absolute value to be a reflection about the x-axis. And so it actually points downwards. Okay? So it opens downward. So that's something that, and really the only thing that's helpful about identifying that ahead of time is that you, is basically that you, like know what you're, like you know if your graph's right or wrong. So if I go about graphing this and I get an absolute value that looks like that, I did something wrong, okay? So that's something to keep in mind. Okay, I'm going to have you on a cliffhanger again because we're about at that 10-minute mark, and so I want to move on to the next video. I'll continue number 22 with that.